Hey guys, well, I am looking out my window and it is blizzarding, so I decided I'm just going to go ahead and record a lecture in case class gets canceled tonight, or maybe I'll just cancel it. But you do need to watch this material because I am then not going to go through it in class on Wednesday. I'll just pick up where I leave off after I'm done with this. So anyway, Chapter 11 handouts, we left off on page 13. We're still in section 11.1. And the last little topic here is application problems. And actually, these are pretty much a piece of cake, especially compared to that what we had done previously, the completing the square technique. They basically will just give you a function and they want you to calculate something based on that function. So a very common example is a free falling object. For example, if I were standing in front of you holding a tennis ball in my hand, just like straight out from my body, and if I were to just drop it, how long do you think it would take to go from my hand and hit the floor? So this can be described by something that's called a position function, and specifically s of t is equal to 16 t squared. This function is used to approximate the distance s that an object falls freely from rest as a function of time, t. Okay, so in other words, I hold the tennis ball. When I let go of it, that is time 0. Okay, so let's approximate that we're going to drop it from a height of 6 feet. Find out how long it takes to hit the ground. Okay, so we're just going to substitute into the position function. We know the distance s is 6, because that's what I said right here. So we're going to say 6 is equal to 16 t squared. So we're trying to solve for t, the time it takes. Okay, so divide by 16, and we have t squared equals 6 over 16. And you can just go ahead and divide that out on your calculator. It's actually equal to exactly 0.375. So now we have t squared equals 0.375, and we're just going to apply the square root property to solve for t equals what? So we're just going to take the square root of both sides of the equation. And again, just do that on your calculator. Take the square root of 0.375, and you will find that t is approximately, to 3 decimal places, 0.612 seconds. Okay, so less than a second it would take to drop to the floor. Okay. One thing I want to point out is that when I applied the square root property here, normally when we use that technique, we would do a plus or minus over here. We didn't have to do that here because time is a physical quantity. It can't be negative. So I just knew automatically I only wanted the positive solution. Okay. All right, so I'm going to erase all this and go on to the next page. Oops. I haven't used this software in quite a while, so kind of remembering how to do it. Okay, so section 11.2, the quadratic formula. The objective for the section, solving quadratic equations using the quadratic formula. We already know a bunch of methods for how to solve quadratic equations. The first method, which you already knew before, coming into this class, was if you can factor it and then use the principle of zero products. The second method, we just covered the square root principle. And the third method, we also just covered the other night, completing the square. Okay? So probably the biggest benefit of using the quadratic formula as opposed to any of these other methods is that it always works. I'm not going to write all these words out because it's too slow for me using this stupid little pencil. But that's the big benefit. It always works. Okay? So when you have a quadratic equation in standard form, and again, that would be ax squared plus bx plus c equals 0. Okay. Then the solutions are given by the quadratic formula, which is the following. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay? You must memorize that. I know it looks hideous. Write it down. Say every time you use it, just write the formula down. It will help you remember it. Okay? And I do want to point out that this gives 2 solutions because of the plus or minus right here. Now, I don't want to write them both out. Again, just fat pencil. It's going to take me too long. But the first solution would be negative b plus the square root of b squared minus 4ac all over 2a. That's one answer. And then the second solution would be negative b minus the square root of b squared minus 4ac all over 2a. Okay? So it gives you solution 1 and solution 2 based on whether you have the plus or the minus in the numerator there. Okay? Okay, I'm going to erase that and scooch down. So where does the quadratic formula come from? Because it looks kind of mysterious, like it just comes out of nowhere. But it's really not that mysterious. I'm not going to go through it, but you basically just start from the quadratic equation in standard form, which I already wrote above right here. And then you just do a series of algebraic manipulations, which include using the completing the square technique that we went over the other night. And basically that's what the quadratic formula does, is it completes the square for us, because as you probably saw when we did those problems the other night, completing the square is kind of a hassle. So, all right, then why did we even bother learning how to do that at all? There are certain applications when you want to complete the square. It will give us one technique later in the chapter for graphing a parabola. Additionally, if you go on into pre-calc and or calculus, you will definitely need to know how to complete the square when you study the conic sections, which are circle, ellipse, parabola, and hyperbola. Okay. All right, let me go to the next page. How to use the quadratic formula. So again, you have to start with your equation in standard form. And remember, we want a to be positive. Okay, so you've got ax squared plus bx plus c. Identify what those numbers are, the a, the b, and the c. just whatever those numbers are. And again, A will always be positive. B and C could be positive or negative. You have to go based on the sign here. You could have a minus sign here. You could have a minus sign here. In that case, that would mean that B is negative or C is negative. So you've got your three numbers. You just put them into the quadratic formula. You simplify your result as far as possible. If the answer is a non-real complex number, then you're going to write it in this form, a plus or minus bi. You're going to separate the two parts. Or, equivalently, you could write the two separate, a plus bi, a minus bi. And depending on what the question asks for, you can also write approximate solutions to 3 decimal places. Okay. All right, so let's go through an example. Let me just see if do I have anything else on this page? Oh, I do. I have another example. Okay. So we've got x squared minus 6x plus 8 equals 0. So A is 1. Okay. B is negative 6. And C is positive 8. Okay. All right, so we're just going to take those numbers and plug them straight into the formula. So x equals negative b. So in this case, the opposite of negative 6. It's going to turn into positive 6, of course. And then plus or minus the square root of b squared. So negative 6 quantity squared minus 4 times a, which is 1, times c, which is 8. All of that divided by 2 times a, which is 1. Okay. All right, so let's take another pass through and start simplifying. So again, opposite of negative 6 is positive 6. And then plus or minus square root of, so negative 6 times negative 6 is positive 36. Minus 4 times 8 is 32. And divide by 2. Okay, so 6 plus or minus the square root of 4 divided by 2. And of course, the square root of 4 is 2. So 6 plus or minus 2 divided by 2. Now, it's usually around this point where I would now separate into the two solutions. Okay? So in other words, the first solution is going to be 6 plus 2 divided by 2. So that's 8 divided by 2, which is 4. And then the second solution is going to be 6 minus 2 divided by 2. So that's 4 divided by 2, or 2. Okay. So those are the two solutions. And we already knew that because this is the problem we had previously solved. Well, first we solved it by just looking at a graph of it, and then we went back and we solved it by factoring. So in this case, this one is very easy to factor. It would be x minus 4 times x minus 2. So if they're very easy to factor, then that's probably the easiest way to solve it. The quadratic equation was a little bit of overkill for this problem, but that's okay. All right, Pause this if you want. I'm going to erase all this and go to the next example. Okay. So x squared plus 13 equals 6x. So first we need to get it into standard form. So I'm going to subtract the 6x from both sides. So we're going to get x squared minus 6x plus 13 equals 0. Okay. And you probably notice right away that this one is not factorable. Okay. So let's use the quadratic formula. All right, again, let's identify A, 1 again, B is -6, C is 13. Okay, take those numbers, plug them into the quadratic formula. So x equals -b. All right, let's just do this all at once. The negative of -6 is +6. Okay, plus or minus the square root of b squared. Okay, again, -6 quantity squared is going to be 36 minus 4 times a is 1 times c is 13. All over 2a. All right, so 6 plus or minus the square root of, what is 4 times 13? 52. Okay, so that's 52. So let's just go ahead and write that. 36 minus 52. All over 2. All right, so it equals 6 plus or minus the square root of 36 minus 52 is -16 over 2. Okay, so notice that we have a negative number in there. So an I is going to come out. And then we've got the square root of 16, which is 4. All right, so it's going to be 6 plus or minus 4i divided by 2. Okay. And notice that we can take a factor of 2 out of both of these. All right, because 6 divided by 2 is 3. 4 divided by 2 is 2. All right. So that effectively gets rid of our denominator. So now what we have is 3 plus or minus 2i. And again, that means two solutions. 3 plus 2i and 3 minus 2i. Okay. All right, pause for a minute. I'm going to erase that and go on to the next page. Okay, I think these are for you. Yeah. Okay, so these two problems. So just go ahead and pause, try the problems yourself, and then come back and watch, and I will go through the solutions. And it looks like in both cases I want the exact solutions, and then from those solutions list your x-intercepts for the graph, if there are x-intercepts. Okay, well, let's see how you did. Let me just list the answers first, and if you have them, then you can just fast forward through this. So for the first one, hold on, I got to find it in my notes. Okay, here we go. You should have gotten the two solutions are x equals -3/2 and 5. And then that means that the x-intercepts would be, I'm just going to say this, not write it. The first point would be -3/2, comma 0, and the second point would be 5, comma 0. Okay. And for number 2, 4x squared plus 3x plus 1 equals 0. Yeah, okay. Your solutions should be -3/8 plus or minus square root of 7 over 8I. So again, that's two solutions. -3/8 plus the square root of 7 over 8I, and -3/8 minus the square root of 7 over 8I. And of course, there are no x-intercepts. So this parabola is completely above the x-axis. Okay, so if you're good, then just go on. Otherwise, I'll go back right now and do the solutions to both of these problems. Okay, so for number 1, a equals 2, b equals -7, and c equals -15. All right, so the solutions are x equals -b, which is going to be +7, plus or minus the square root of b squared. -7 times -7 is +49, minus 4 times a, which is 2, times c, which is -15, all over 2a. So 2 times 2. All right, so 7 plus or minus the square root of 49 minus, okay, let's see, -15 times 2 is -30. -30 times 4 is -120. And I guarantee you that if you made a mistake, it was right there. Let me come back to that thought in a second. Okay, divided by 4. So this is the most common mistake that I see people make, because you're doing b squared minus, and then in this case, when we do 4 times a times c, that is a negative quantity. So we're doing minus a minus, which then, of course, turns into a plus. Okay? So it's actually going to be 49 plus 120 underneath the radical. All right, so 7 plus or minus the square root of 49 plus 120 is 169 divided by 4. And this works out nicely because 169 is a perfect square. It's 13 squared. So it's 7 plus or minus 13 divided by 4. Okay. Split into the two solutions. So I'm going to have 7 plus 13 divided by 4. Okay, 7 plus 13 is 20. 20 divided by 4 is 5. And the second solution is 7 minus 13 divided by 4. Okay, 7 minus 13 is negative 6. So it's negative 6 over 4, but we have to simplify that fraction. Take a factor of 2 out of both. So there's where you get your negative 3/2. All right, pause it if you want. I'm going to erase all that and scooch down. Okay, to this one. All right, so for this one, oh shoot, come on, pencil. We've got A equals 4, B equals 3, and C equals 1. All right, so x equals negative b, so negative 3, plus or minus the square root of b squared, so 3 squared is 9, minus 4 times a, which is 4, times c, which is 1, all over 2a, so 2 times 4. All right, so x equals negative 3 plus or minus the square root of, let's see, this is 9 minus 16 under the radical. Okay, so 9 minus 16 is negative 7, and then divided by 2 times 4 is 8. All right, so again, we see the negative sign under the radical, which indicates that we have to bring an I out, and then we can't simplify the square root of 7. All right, so it's going to be negative 3 plus or minus I times the square root of 7 over 8. All right. And then in this case, we want to separate the real part from the imaginary part. So in other words, negative 3 over 8 plus or minus square root of 7 over 8 times I. And again, that represents two solutions. I just don't feel like writing them both out. Negative 3/8 plus square root of 7 over 8i, and negative 3/8 minus square root of 7 over 8i. All right, I'm going to go on, erase all this and go on. Okay. Summary of solving quadratic equations. So again, the standard form for a quadratic equation is, you guys go ahead and write this down, I'm not going to write everything, ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is positive. The general form of a quadratic function is, so we would have our f of x equals ax squared plus bx plus c. This function describes the graph of a parabola, P-A-R-A-B-O-L-A, parabola. To solve a quadratic equation means find the values of x that make it true, or in other words, find the values of x that make the function, the y value, equal 0. Okay, those are the x-intercepts. Those are the places where it cuts through the x-axis. The possible solutions are either two different real numbers, which means that the parabola has two x-intercepts. You could end up with just one real number, which means the parabola has a single x-intercept. Remember, we looked at these the other night. So for example, this one cuts through the axis like this. This one, it just touches the axis, just at that single point. Or two non-real complex numbers, which means the parabola has zero x-intercepts. It is completely above or completely below the x-axis. So you have now studied 4 different ways to solve quadratic equations. One you previously learned a long time ago, back in chapter 5, whenever you did that, and then 3 methods that we just learned in this chapter. So I just kind of like to run over the methods, the requirements, and kind of the pros and cons. So the method that you already knew coming into this class was the factoring, and then using the principle of zero products. You can only use this if your quadratic equation is factorable, which is not usual. It's very easy, so you should just check first and see if it's factorable. The minus is, again, usually they are not factorable. The principle of square roots, we talked about that the other night. You've got to have a quadratic in the form x squared equals d, where d is just a number, or you can have x plus c, any number, quantity squared, is equal to some number. Okay? So the plus for that is that it's very easy. Remember, you just take the square root of both sides, and remember, in this case, to apply your plus or minus. That's where you get the 2 solutions. So it's easy. Usually quadratics don't just happen to be in that form. Okay? Completing the square, you need to put your equation into this form. So if it's not, well, it's not already, so you need to put it into this form by completing the square. This method always works, but it's kind of a pain. I personally would never use this method to solve a quadratic because it's too much of a pain. Okay? And then the last method that we just covered, the quadratic formula. What does this say up here? Requirements. Oh, none. Just put it into standard form, which again, ax squared plus bx plus c equals 0. It always works, and there's really no downside unless you have one that is very easy to factor. Then you might want to do that first. All right, I'm going to pause here and then go on to the next section. Hey guys, I'm back. I also just discovered I'm an idiot because I just spent about half an hour recording part of this section, and then I realized I actually had it on pause the whole time, so I'm really pissed right now, but I'm trying to get over it. Anyway, okay, section 11.3, applications, everyone's favorite. The objectives are to solve word problems where the equation is a quadratic, and at the end of the section, solving a formula for a given variable. Okay, so word problems, and actually this kind of works out nicely because you are working on, or you should be working on, some problems from section 8.4 right now for your assignment that is due on Wednesday. Those are word problems with two variables and two linear equations. And then line this one out because we did not do section 10.7. It is not going to be on the final. So what's different in this section from what you are reviewing in section 8.4 is that when you write the equation describing the problem, it's going to be a quadratic equation instead of a system of linear equations. So you're going to get a quadratic equation. You're going to solve it using one of the methods we just finished covering. And just a comment that you need to be on the lookout for extraneous solutions. So just a word of explanation, when you solve your quadratic equation, you generally end up with two solutions. And usually the problems that you'll be solving only need one of those solutions. So one of those will be the right solution and one of them will not. The other one is the extraneous one and you just throw it away. For example, if you're solving for the length of something, and if you get your two solutions and one of them is negative, that can't be the right solution because length cannot be negative. So generally you can figure out which one is the right answer. So there's a number of different types of problems in this section. I tried to just group them into categories: rectangle area, triangles, picture frames, consecutive integers, motion problems. I'm going to do an example of most of these, maybe not the consecutive integers. You can look at the book and figure those out. And the book solves most of these using a single variable, which is different than how you were doing it in section 8.4. The only exception to that is the motion problems, and I will do an example of one of those. All right, so let's move on to the first problem on the next page, rectangle area. Get my pencil going. The length of a rectangular computer part is twice the width. The area is 242 centimeters squared. Find the length and the width. Okay, so just start by drawing yourself a rectangle. We don't know either the length or the width, so let's just call the width x. And then we know that the length is twice that, twice x, in other words 2x. So the length can be written as 2x. And we know that the area equals 242. And of course the area of a rectangle is just the length times the width. So in other words, area, which is known to be 242, is equal to the length, 2x, times the width, x, or 2x squared. Okay. All right, so we want to solve for x squared equals a number. So let's just divide both sides of the equation by 2. And then we'll end up with x squared equals 121. And then using the square root method, we just take the square root of both sides. And of course, when we use this technique, it would be plus or minus. So x equals plus or minus 11, because that's the square root of 121. X equals 11 or negative 11. But in this case, obviously, it can't be negative 11 because that's not possible. So really, the solution is just x equals 11. And then making sure we answer the complete question, it says to find both of them. All right, so one dimension is 11 centimeters. The other dimension is twice that, or 22 centimeters. All right, I'm going to move on to the next page. All right, triangle problem. And this is one we're going to use the Pythagorean theorem for. The hypotenuse of a right triangle is 22 meters long. The length of one leg is 10 meters less than the other. Find the lengths of the legs. Okay, so it's a right triangle. So let's just draw one. All right, there's my 90-degree angle. The hypotenuse is always the longest one. It's opposite the right angle. The length of one leg is 10 meters less than the other. All right, well, let's call this one x. And then we want to write an expression for the other leg in terms of x. Well, the other one is 10 less. 10 less than x. In other words, x minus 10. Okay. So that's our picture. And now we just need to apply the Pythagorean theorem. So just a quick reminder on that. And again, this is only for right triangles. The two legs are typically called A and B, and the hypotenuse is C. And the Pythagorean theorem says that A squared plus B squared equals C squared. Okay. So that's exactly what we're going to use to write our equation. So here's the first leg, x minus 10. All right, so x minus 10 quantity squared. Here's the other leg, plus x squared equals hypotenuse squared, 22 squared. All right, x minus 10 squared, remember we need to expand that. That means x minus 10 times x minus 10. All right, so we're just going to FOIL that out, and we'll get x squared. Then we have minus 10x minus another 10x, which will be minus 20x. Minus 10 times minus 10, so plus 100. And then plus x squared. Equals 22 squared, which is 484. All right, now I want to get this into standard form. Ax squared plus bx plus c equals 0. So just all stuff equals 0. All right, so on this side I've got an x squared, I've got another x squared, so that makes 2x squared. And then minus 20x. And then I'm going to subtract 484 from both sides. So minus 484, minus 484. 100 minus 484 is minus 384. And that equals 0. So there's our quadratic. And we could solve it now, but my suggestion is this. If you notice all of these are even, we can take a factor of 2 out of all of them. So we can divide this entire equation by 2. Okay, just to make it easier, get the numbers to be a little smaller. So then we're going to end up with x squared minus 10x minus 192 equals 0. Okay. There's a quadratic we want to solve. Don't know if it's factorable, and if it's not immediately obvious, then just use the quadratic formula. Okay. So A is 1, B is negative 10, and C is negative 192. So plug them in. X equals negative B, so that's going to be positive 10, plus or minus the square root of, oh crap, okay, let me see if I can actually pause this. Okay, I'm back, sorry about that. Alright, so X equals negative 10 plus or minus the square root of, okay, B squared, so negative 10 squared is 100, minus 4 times A is 1 times C is negative 192. And all divided by 2 times A is 1, so that's just divided by 2. Let's see, so 10 plus or minus the square root of, let's see what we got up here. And again, notice that C is negative, so minus a minus, that's going to turn into a plus. So it's going to be 100 plus whatever this is. And that is 192 times 4 is 768. So we're doing 100 plus 768, which is 868, and then divided by 2. Okay, so, and let's see, it asks us up here for the exact and the approximate answer to 3 decimal places. So this is the exact answer that we're working on here, but the thing is we need to make sure that we have it fully simplified. In other words, does 868 have any factors that are perfect squares that can be removed from under the radical? All right, well, let's make a factoring tree. I'm going to come up here off to the side. So 868, obviously we can take out a 2, and that is 434. So, okay, obviously we can take out another 2, and that is 217. And that looks prime. This one's a little tricky. It's actually not. 217 happens to be 7 times 31. So these are all the prime factors. 31 is prime. So in other words, 868 equals 2 squared, so there is a square under there, times 7 times 31, which is 217. Okay. So in other words, back down here, under the radical, I have 2 squared times 217. So I'm going to take that 2 out from underneath. So we're going to have 10 plus or minus 2 times the square root of 217, all divided by 2. And now what you should notice is that you can take a factor of 2 out of both of these terms. In other words, if I do the 10 divided by 2, it's 5. And then the 2 divided by 2 is just 1. Okay? So the bottom line here is we have 5 plus or minus the square root of 217. Okay, so that is 2 solutions, and we need to figure out which one is the correct one. Well, let's write them both out. I'm going to come back up here. Okay, so that means it's either 5 plus the square root of 217, or it's 5 minus the square root of 217. Okay. And this is a good example of where it's actually more helpful to have the approximate solution, the decimal number, because these numbers are not very useful. So just compute these on your calculator. Just do 5 plus the square root of 217, and you'll find that that is about 19.731. I think it says to 3 decimal places, yeah. And then if you do 5 minus the square root of 217, you should find that that is about negative 9.731. Okay, so that tells us that this can't be our solution because it's a negative number and we're solving for a length and it can't be negative. All right, so this is the exact solution for the one leg. This is the approximate solution for the one leg. So that is x that we just solved for. Notice that it says to find the lengths of the legs, in other words, both of them. Okay, so we know what x is now, so now we just have to find out what x minus 10 is. Well, we know that x is 5 plus the square root of 217. And we just want to know what x minus 10 is. Okay, so we can just go ahead and, combine these two numbers. 5 minus 10 is minus 5. So minus 5 plus the square root of 217. Okay, so that is the exact length of this leg. And then if you just compute that on your calculator, you should find out that that is approximately 9.731. Right? Okay, I'm going to go on to the next page. Okay, so the picture frame type problems, these are basically just a twist on the rectangle area problems. But I just want to show you how they work because, as usual, the hardest part is just setting up and understanding how to write the equation. And in this case, I took this picture, it's straight out of the book. It's actually very nice. They were very generous that they actually labeled the variable for you. So that should make it easier. Okay, so the outside of the picture frame measures 14 inches by 20 inches and 160 square inches of picture shows. Find the width of the frame. So in other words, the area is just the picture. It does not include the frame. Okay, and so what we want to find is the width of the frame, which, as you can see, is the same width all the way around. So that has already been labeled as our variable x. That's the unknown. Okay, so what we need to do is come up with an expression for the length and the width of just the picture, not including the frame. See, we know that this total length is 20, but this length doesn't include this part, x, or this part, x. So in other words, this is the whole thing, 20, but I have to subtract off x, and then I have to subtract off another x. All right? So in other words, this dimension of the picture is 20 minus 2x. And then similarly, this dimension of the picture, the total distance here is 14, but again, that includes x and another x. So this dimension is going to be 14 minus 2x. Okay. And again, just using the fact that the area is equal to the length times the width. And we know the area of the picture, it's 160. And now we have an expression for the length. It's 20 minus 2x. And an expression for the width, which is 14 minus 2x. Okay. So what we need to do is just FOIL on the right-hand side here. So I do 20 times 14, which is 280. And then when I do the 20 minus 2x, that's minus 40x. Minus 2x times 14, that's minus 28x. And minus 2x times minus 2x is plus 4x squared. Okay, so now we want to combine our like terms, get everything on one side so that we have all stuff equals 0. I'm also going to put the terms in the correct order, so I'm going to put the 4x squared first. And then minus 40x minus 28x would be minus 68x. And then we want to subtract 160 from both sides. So minus 160 minus 160 on this side gives me plus 120. Oops, sorry. Erase. And that is all equal to 0, which is exactly what we want. If you happen to notice, all of these coefficients are divisible by 4, so it will make our equation a lot easier if we just divide both sides of the equation by 4. So now we're going to have 0 equals x squared minus 17x plus 30 equals 0. Oh, I already have the equals 0. All right, and we could just jump in with the quadratic formula, but this is a case where this factors, and it's actually going to be a lot easier if we just factor this. So if you look at it, you should see that it would factor as x minus 2 times x minus 15. Okay, meaning that the solutions are either x equals 2 or x equals 15. Okay, and then we have to pick which is the right solution. Well, if you come back to the figure, this entire length here is only 14 inches. So it is physically impossible for x to be 15 inches. Okay, so in this case, that is the extraneous solution that gets discarded, and this is the answer. Okay, the width of the frame is 2 inches. Okay, and finally, for everyone's favorite, motion problems. And again, we're going to use the same formula and the same basic method as from section 8.4, some of the problems that are on your homework assignment for this week. So of course, the formula is distance equals rate times time. Okay. If you're driving at, say, 70 miles per hour for 2 hours, then you're going to go 140 miles. That's, how the formula works. And this is the method that I always use and that I recommend, is to just set up a table. So you can keep all your information organized in that tabular form. There's always two parts to the problem, okay? During the first part of a canoe trip, he covered 60 kilometers at a certain speed. He then traveled 24 kilometers at a speed that was 4 kilometers per hour slower. So that is the second part, okay? So the first part and then the second part, okay? And the second part is kind of defined by the fact that he was going slower. Okay, so what can we fill in? So we've got distance equals rate times time. The first part, he went 60 kilometers at a certain speed. Okay, we don't know what that speed was. He then traveled, so now we're in the second part, 24 kilometers. Okay. At a speed that was 4 kilometers slower. Okay, so we don't know either of these speeds, but we know something. We know that this was 4 less than this. So if we call this R, then this is R minus 4. Okay. If the total time for the trip was 8 hours. Okay, so again, I don't know the individual times for either part, but I know that together they make 8 hours. Okay, so let's call this T. Then this has to be what? Has to be 8 minus T. Because together, if you add them together, 8 minus T plus T, the sum is 8. So that's kind of how you can figure that out. Okay, so then for each part, we can write an equation. Okay, so the equation for this is just 60 distance is equal to rate times time, RT. And for the second part, we have distance, 24, is equal to rate, R minus 4, times time, 8 minus T. Okay, so now the technique is, and you might want to jot this down. I'm not going to write it down. It would take me too long. Solve both equations for the same variable, either for R or T. Solve both equations for the same variable, either for R or T. Next, substitute one expression for R or T into the other equation. Third, now you will have a single equation in terms of only one variable, either R or T. Finally, solve the equation. Okay. So in this problem, we are trying to find the speed, the rate. Okay. Therefore, I think that the best thing to do is solve both equations for T. Because then we will end up eliminating T, and that's what we want. We want to end up with an equation just in terms of r. Okay? All right, so this is my equation number 1. Let me come down here. I want to solve that for t equals what? Well, that's easy. All I have to do is just divide both sides by r. So I end up with t equals 60 over r. Okay. And then I have equation 2, this one. Okay. 24 equals r minus 4 times 8 minus t. So the first step is we're going to divide both sides of the equation. Let me erase that. Going to divide both sides of the equation by r minus 4. Okay. Because that cancels here. So now what we have is 8 minus t is equal to 24 over r minus 4. Remember, the goal here is to get t equals stuff. So, okay, we can kind of do two things at one time here. Because we've got a minus t, I hate having minuses. So let's add t to both sides of the equation. So on this side, we're just going to have all this junk plus t. And then at the same time, all this junk, let's just subtract it from both sides of the equation. Okay? So we will end up with t equals 8 minus 24 over r minus 4. Okay. All right, so now do you see that I've got t equals stuff and I've got t equals stuff. So we're just going to take this stuff and set it equal to this stuff because they both equal t. They're the same. Okay. So I've got 60 over r is equal to this stuff. 8 minus 24 over r minus 4. Okay. So these are the types of equations that you guys already reviewed, I think from chapter 6. We have a couple of different denominators, and our least common denominator is r times r minus 4. Okay. So the technique is to multiply through the entire equation by that least common denominator. So in other words, every single term has to get multiplied by r times r minus 4. So I'm multiplying the first term, I'm multiplying the second term, and I'm multiplying the third term. And the whole point of this technique is that we can cancel out the denominators. Okay? So for example, on this one, this r cancels this r. On this one, nothing cancels. On this one, the r minus 4 and the r minus 4 cancel. So then we just see what we have left. Here I've got 60 times r minus 4. Okay. and that's equal to, here I've got everything, so I've got 8r times r minus 4 minus, here I've just got 24 times r, so 24r. Okay. So now we just got to start multiplying out, getting rid of the parens, and then we will combine terms and simplify. All right, so I've got 60r minus 240 equals, all right, when I do this, I've got 8r squared, and then minus 32r, and then minus 24r. Okay, so we need to get all stuff on one side equals 0 on the other side. We want to get everything on this side because this is where my r squared term is. So we will subtract 60r from both sides to get rid of that. And we will add 240 to both sides. All right, I'm going to move up here now. Hold on a second. Okay, sorry, where was I? So we're down here. We want to start collecting all our like terms on the right-hand side of the equation. Okay, so we have 8r squared and then if we collect all these r's, so minus 32r, minus 24r, minus 60r becomes minus 116r. And then the constants, oh, that's the only one, so plus 240. And that all now equals 0. Okay. All right, so there's our quadratic equation. Again, let's look and see if we can simplify it at all before we start to solve it. We can't divide an 8 out, but we can divide out a 4. So divide both sides of the equation by 4. Again, this is just to make it a little bit easier. And then we end up with 2r squared minus 29r plus 60 equals 0. Okay. All right, and at a glance, I don't feel like trying to factor it, so let's just use the quadratic equation. We have a equals 2, b equals negative 29, and c equals 60. Okay, so r equals negative b, which would be positive 29, plus or minus the square root of quantity negative 29 squared minus 4 times a, which is 2, times c, which is 60. All of that divided by 2 times a, which is 2. Okay? All right, so 29 plus or minus, okay, so negative 29 squared is 841, and then minus this stuff is 480. Okay, So 841 minus 480 is equal to 361. All of that divided by 4. Okay, the square root of 361 is 19. So 29 plus or minus 19 divided by 4. Okay, so this is a good time to split into the two solutions. So it's either 29 plus 19 divided by 4. So that would be 48 divided by 4. Which is 12. Or it's 29 minus 19 divided by 4, or 10 divided by 4. And if we just put that in decimal form, it's 2.5 or 2.5. Okay. All right. So, and again, we are solving for R. And remember that R is the faster rate, the rate on the first part of the trip. Oh my freaking gosh, hold on, I am so sorry. Okay, sorry again. My husband is absolutely driving me insane. Let me see if I can get through this. Okay, so where was I? We've got our two solutions for R, either 12 or 2.5. R represents the faster rate. The slower rate is R minus 4, which tells us that this cannot possibly be the solution, because 2.5 minus 4 would then be a negative number. Okay, so this is not it. So the answer must be this. R equals 12. Okay, so R equals 12, and that's what? Kilometers per hour. And what did it ask for? The speed on each part. So if this is 12 kilometers per hour, then this is 12 minus 4, or 8 kilometers per hour. Okay? So those are the two answers to the problem. All right, let me see what I've got on the next page. Okay, couple of problems for you guys to work on. So go ahead and try these. First one is a consecutive integer problem. Okay, and if you don't remember how to set up the algebraic expressions for that, then look in the book. I'm sure that they have an example of that. So you're looking for two consecutive pages, which have to be two consecutive integers. All right, and then the second one is kind of like the picture frame problem. All right. So anyway, I'm going to leave you now. Go ahead and work on those. I want to get this video posted, so I'm going to just stop here. I'll either make a separate video with the solutions to this later, or I'll just post a file. All right, I'll see you guys Wednesday.